You think you know what the word big means. You have stood on a beach and watched the ocean run out past the edge of the world. You have looked up at a mountain that filled the whole sky, and somewhere inside you there is a quiet, private sense of the largest thing there could ever be. But here is what no one tells you. There is a single object out in the universe that your imagination simply cannot reach, no matter how hard you push it, and tonight we're going to walk slowly up to the exact place where your sense of scale gives out. It is a black hole called Ton 618, and by the most widely quoted measurement, it weighs more than every star in our entire galaxy combined. The edge of it is 40 times wider than the orbit of Neptune. It is so large that light, the fastest thing in all of existence, needs 2 full weeks just to cross from one side of it to the other. You're going to know exactly how big it is by the end of tonight, every number, measured and real, and you still will not be able to picture it. That failure, strange as it sounds, is one of the most genuinely beautiful things a human mind can feel. Get comfortable. Hit subscribe if you're new here, because by the end of this, the word big will never quite mean what it used to. Now, let's slowly ease into this. Part 1. The word big has a limit. Somewhere in your life there is a thing you think of when you think of the word big. Maybe it's the ocean, seen for the first time from a beach as a child, the water running out to a horizon that did not seem to end. Maybe it is a mountain that filled the whole windshield as you drove toward it, or the floor of a canyon looked down upon from a trembling edge, or the moment a plane lifted above the clouds and the land below turned into a map. Whatever it is for you, you carry it quietly, and you measure other things against it without ever noticing that you are doing it. It is your private ruler for the size of the world, built from the largest things your own 2 eyes have ever stood in front of. Tonight I want to take that ruler gently out of your hands and break it. Not to frighten you, and not to make you feel small in the way that word usually means, but because there is a single object in the universe that cannot be measured against anything you have ever seen. And the only honest way to meet it is to admit, before we begin, that your imagination is going to fail. It is going to fail, not because there is anything wrong with your imagination, but because it was assembled on the surface of one small world, out of mountains and oceans and the longest journeys you have ever taken, and the thing we are walking toward tonight does not belong to that world or to any scale your mind was ever shaped to hold. The object has a plain and almost disappointing name. It is called Ton 618, and the name is just a number in an old catalogue of faint smudges of light, the kind of name a thing gets when nobody yet understands what they are looking at. For years, in fact, nobody did. It sat in the records as an unremarkable speck, mistaken for a dim star, filed away and forgotten, and then, slowly, as the light was understood, the speck turned out to be one of the most enormous single objects ever found anywhere in the universe. A black hole with a mass that the most widely quoted measurement puts it around 66 billion times the mass of our Sun. I'm going to say that number again, because I want you to notice what happens inside you when you hear it. 66 billion times the mass of the Sun. You heard the words, you understood each one of them, and almost certainly nothing happened. No picture formed. There was no image behind your eyes of 66 billion suns, because there could not be, because a number that large does not turn into a picture the way smaller numbers do. You can imagine 3 apples. You can, with some effort, imagine 1,000 people in a stadium. But somewhere on the climb from 1,000 to 1,000,000,000 to 66 billion, the pictures stop, and all that is left is the words. And that gap, the gap between reading a number and seeing it, is the real subject of everything we're going to do tonight. Here is the thread I want you to hold on to as we go, because everything else hangs from it. A number is not the same as a size. We treat them as if they were, because for all the ordinary quantities of human life they really are close enough. 12 eggs, 100 miles, $1,000,000, these are numbers you can feel as well as state. But the universe deals in quantities so far past the human range that the number and the size come apart completely, and you're left holding a true fact you cannot actually picture. Ton 618 is the sharpest example of that gap I know of. By the time we are finished, you will know exactly how massive it is, exactly how wide, exactly how far away, and you will still not be able to see it in your mind. And I want you to understand going in that this is not a failure of the video. It is the whole point of it, so we are not going to rush at the number. Rushing at it does nothing. I could tell you 66 billion in the first 10 seconds and it would slide off you like water off glass, which is exactly what happens in every short clip and every quick fact post that throws the figure at you and moves on. I want to be honest with you about why the slow way is the only way that works, because it explains the whole shape of tonight. Your imagination is not a calculator. It does not deal in raw numbers at all. It deals in comparisons, in relationships, in things stood next to other things. When you picture something large, what you're really doing is remembering something you have seen and stretching it a little, the way you might imagine a building twice as tall as the tallest one you know. That trick works beautifully up to a point, because most large things in human life are only a few stretches away from something you have actually stood beside. But the trick has a breaking point, a place where the thing you are trying to picture is so many stretches removed from anything you have ever seen that the chain of comparison snaps and the mind is left holding a word with no image attached. Tonight is a guided walk to exactly that breaking point, and the only way to find it honestly is to follow the chain of comparisons link by link until you feel it give. Throw the final number at someone cold, with no chain leading up to it, and they feel nothing, because there is nothing for the number to attach to. Build the chain first, carefully, and the same number becomes one of the most powerful experiences a mind can have. There is one more reason to go slowly, and it is the reason this channel exists at all. The point of a night like this is not really to deliver a fact about a black hole. You could read the fact in a sentence and forget it by morning. The point is the feeling that comes when your own mind is stretched right up to its limit and held there. The particular quiet thrill of standing at the edge of what you can comprehend and looking out past it. That feeling cannot be rushed, and it cannot be handed to you. It has to be built slowly, in your own head, one comparison at a time, until you arrive at the edge under your own power and feel it for yourself. So if you have come here tonight to drift, to let your thoughts loosen and your breathing slow while we wander together up the ladder of scale, then you have come to exactly the right place, because we are going to take our time. We are going to linger on each rung, and the prize at the top is not a number you will memorize. It is a moment of genuine wonder that will stay with you long after you have forgotten the exact figures, the clean and humbling sense of how large the universe truly is, and how small and how remarkable it is that we can know any of it at all. Instead, we are going to climb to it. We are going to start with things you can actually picture, the things on your private ruler, and we are going to step from each one to the next, slowly, letting each rung settle before we reach for the one above it. We will climb from the ground you're lying on to the planet, and from the planet to the sun, and from the sun out past the planets, to the cold edge of our own solar system, and from there to the stars, and from the stars to the whole turning wheel of the galaxy. And at each step you will feel, I hope, the pleasant strain of a mind being stretched a little past its usual size. And then, near the top of that climb, when you're already standing somewhere your imagination has rarely been asked to go, we will finally arrive at the thing itself, and you will feel the rung give way beneath you. That is the moment I am building toward. Not the delivery of a fact, but the precise instant your sense of scale runs out of floor. It is a strange thing to look forward to, the failure of your own imagination, but I promise you it is one of the most genuinely wonderful feelings the universe has to offer, and almost nothing in ordinary life will ever give it to you. The only price of admission is patience, and a willingness to be made small. So get comfortable, wherever you are. Let your breathing slow. We are going to take a walk up the ladder of size, and we are going to take it one careful step at a time, because the thing waiting at the top has been sitting out there in the dark for billions of years, indifferent to whether anyone ever understood it, and it is in no hurry at all. Neither are we. Let us begin where you already are with the solid ordinary ground beneath you, and let us see how far up we can climb before the words and the pictures finally come apart for good. Part 2. Climbing the first rungs. Start with your own body, lying or sitting wherever you are. This is the bottom rung of the ladder, the scale you live at, the size of a thing that can fit through a doorway and stand under a tree. Everything you have ever physically touched lives within a few steps of this rung, and from here, the first climb is one you have made before, even if only in your imagination, so it should feel familiar and easy. Pull back from your body until you can see the room, then the building, then the town spread out beneath you like a circuit board, then the curve of the coastline until the whole planet hangs below you as a blue and white sphere turning slowly in the black. The earth feels enormous, and from where you usually stand it is. A person walking without stopping would need most of a year to cross it on foot. The largest oceans take a passenger jet the better part of a day to fly across. Everything that has ever happened to every human being who has ever lived, every war and every city and every love story in all of history, happened on the thin skin of this single ball of rock. For almost all of human existence, this was the whole of the known world, the outer edge of the ruler, the biggest thing there was. So let us honour it as the first real rung. The Earth is big, hold that feeling, because we are about to make it small. Now bring the sun into view. You have seen the sun every clear day of your life, and at that distance it looks like a coin, a bright disk you can blot out with a thumbnail. But the sun is not a coin, and it is not nearby. It is a star, the same kind of object as the points of light you see at night, and it only looks small because it is so far away. If you could set the Earth down next to it, the comparison would stop being a comparison and become a kind of joke. You could line up more than 100 Earths across the face of the sun just to span its width, and to fill its volume, to pack the whole inside of the sun with Earths, you would need somewhere around 1 million of them. 1 million Earths poured into one star, and that star is an ordinary one, a middling yellow light among hundreds of billions of others. And I do not want to let the sun go by as just a number, because the sun is the most important rung on this entire ladder, the one everything else is measured against. The sun holds more than 99% of all the matter in our entire solar system. Every planet, every moon, every asteroid and comet, all the worlds combined, amount to less than 1% of the leftover scraps. The sun is almost the whole of it, and the planets are the crumbs that did not fall in. It is a sphere of glowing gas so large and so hot that its core is squeezed to temperatures of millions of degrees, fusing hydrogen into helium at a rate that turns millions of tons of matter into pure light every single second, and has been doing so steadily for almost 5 billion years, with billions more to come. This is the object we are going to use as our basic unit for the rest of the night. Every time I say a number of suns, I want you to remember this. Not a coin in the sky, but a furnace 1 million Earths could fall into, the anchor of an entire solar system, the source of nearly all the light and warmth that has ever touched our world. Hold that as your unit of one, because the thing waiting at the top of the ladder is going to be measured in tens of billions of them. Sit with that for a moment, because it is the first place the ordinary ruler starts to bend. The Earth, the thing that took a year to walk across and held all of human history, is a grain beside the sun. 1 million of them inside a single average star, and the sun is not even a large star. There are stars out there, red giants and supergiants, that would swallow the sun the way the sun swallows the Earth, stars so enormous that if you placed one where the sun is, its surface would reach out past the orbit of Mars and engulf the inner planets entirely. We have not even left our own little neighbourhood, and already the rungs are stretching faster than the mind likes to follow. Let me hold us on those giant stars for just a moment longer, because they are a useful warning of what is coming. Picture one of the true supergiants, a star near the end of its life, swollen to monstrous size. If you set such a star down where our sun is, its glowing surface would swallow Mercury, swallow Venus, swallow the Earth, and keep going, out past Mars, filling the entire inner solar system with star. Everything you have ever known, the whole of the ground beneath you and the air above it, would be deep inside the body of a single star, with the surface still far overhead. That is one star, not a galaxy, not a black hole, just one swollen sun among the hundreds of billions in our galaxy. And already, at just this rung, the mind begins to protest, because you cannot really picture standing inside a star the width of the inner solar system. You can only state it. Notice that feeling now, while it is still mild, because it is the same feeling we're walking toward, only gentler. The protest you feel at a star that swallows Mars is a small cousin of the collapse you will feel at a black hole that swallows the entire solar system 40 times over. The ladder we are climbing does not introduce a new kind of strangeness at the top. It just turns up rung by rung, a strangeness that is already here, already pressing faintly against the edges of your imagination, even now, even this early in the climb. Now let us pull back further and take in the whole solar system, the sun and everything that orbits it. Picture the sun as a single bright point and start counting outward. There is Earth, close in, taking 8 minutes for the sun's light to reach it. Keep going. Mars, then the wide gap of the asteroid belt, then mighty Jupiter, then Saturn with its rings, and the light that crossed from the Sun to Earth in 8 minutes now takes well over an hour to reach these outer worlds. Keep going still, out past Uranus and Neptune, the far cold giants, where sunlight takes 4 hours or more to arrive, and the Sun itself has shrunk to just another bright star. Neptune orbits at 30 times the distance from the Sun to the Earth, and even that is nowhere near the true edge. Because beyond Neptune the solar system keeps going, far past where most people imagine it stops. There is a wide belt of icy worlds out there, and beyond that a thin wind of particles streaming from the Sun that finally peters out around 120 times the Earth-Sun distance, in a region the spacecraft Voyager only crossed after decades of flight. And beyond even that, wrapped around the whole solar system like an enormous faint shell, there is thought to be a cloud of frozen comets reaching out thousands and thousands of times farther still, perhaps a quarter of the way to the nearest other star. The solar system is not the neat little diagram of 8 planets from the textbooks. It is an immense and mostly empty sphere, and light, the fastest thing there is, needs the better part of a day just to cross its inner regions and far longer to reach its true frontier. And now make the most punishing step of all, the one that always breaks people a little. Leave the solar system and travel to the nearest other star. That star, Proxima Centauri, is the closest one to us in the entire universe, our next-door neighbour in the galaxy. The Sun's light reaches Earth in 8 minutes and reaches distant Neptune in 4 hours. To reach Proxima Centauri, that same light, moving at the absolute speed limit of reality, needs more than 4 years. 4 years of travel at the speed of light just to reach the very nearest star, and the fastest spacecraft humans have ever built would take tens of thousands of years to make the same trip. The gaps between the stars are so enormous that the distances within our entire solar system shrink by comparison to almost nothing. Now hold all of that in your mind at once if you can, and let me tell you where it leaves us. We have climbed from your body to the planet, from the planet to the Sun, from the Sun across the whole solar system, and from there to the single nearest star, and at every step the previous rung became a speck. And we have not even begun. Because the nearest star is one of several 100 billion stars in our galaxy, and the galaxy is a thing so large that the 4-year crossing to Proxima Centauri is a single short stride within it. The wheel of the Milky Way is so wide that light, which took 4 years to reach the nearest star, needs 100,000 years to cross from one side of the galaxy to the other. Keep climbing. We're not nearly high enough yet, and the thing we're walking towards still lies far above us in the dark. Part 3. The Dark Hearts of Galaxies. Stand now at the scale of the whole galaxy, that immense flattened wheel of several 100 billion stars turning slowly in the night. We arrived here at the end of the last climb almost out of breath, and I want to let you rest at this rung for a moment, because it is one of the strangest and most beautiful places the mind can stand. From far enough above, the Milky Way would look like a pale spiral of light, its arms wound around a glowing central bulge, the whole thing slowly rotating so grandly that a single turn takes hundreds of millions of years. The Sun, with all its planets, and all of human history, is a single dim speck 2/3 of the way out toward the edge of one of those arms, taking 250 million years to make one lap around the centre. We are not at the middle of anything. We are out in the quiet suburbs of the wheel. But it is the centre of the wheel I want to turn your attention to now, because something lives there that we have not met yet on this climb, and meeting it is the next step up. If you follow the spiral arms inward, in toward the bright, crowded bulge at the galaxy's middle, the stars grow denser and the light grows fiercer, and right at the very centre, at the still point the whole galaxy turns around, there sits a thing that gives off no light at all. It is a black hole, and not a small one. The black hole at the centre of our galaxy has a mass of about 4 million suns, all of it crushed into a region of space from which not even light can climb out. 4 million suns gathered into a single dark point, and the entire Milky Way wheels around it. I should pause here and say clearly what a black hole actually is, because it is one of those ideas that everyone has heard of, and almost no one has had explained slowly. A black hole is not a hole in the ordinary sense, not an empty pit or a tunnel. It is the opposite of empty. It is a place where a great deal of matter has been packed into so small a space that the pull of its own gravity has become overwhelming, so strong that nothing which falls close enough can ever get back out again. Not a spaceship, not a planet, not a beam of light itself. We have spoken on this channel before about how gravity is really the bending of space and time around anything with mass. A black hole is simply what happens when that bending becomes so extreme that space and time fold completely over, sealing off a region of the universe from the rest of it forever. The boundary of that sealed-off region has a name. It is called the event horizon, and it is the closest thing a black hole has to a surface, though it is not a surface you could ever stand on. It is more like a line drawn in space, a point of no return. Outside the line, if you're quick enough and your engines are strong enough, you can still escape. Cross the line even by a single step and no force in the universe can ever bring you back, because to come back out you would have to travel faster than light, and nothing can. The size of that line, the radius of the event horizon, depends on just one thing, the mass of the black hole. The more mass, the larger the horizon. And that simple rule is going to matter enormously by the end of tonight, because it means that when we finally reach a black hole of 66 billion suns, we will be able to work out exactly how wide its point of no return must be. For our own galaxy's central black hole, the 4 million sun one, the event horizon is actually rather modest by cosmic standards. Its boundary would fit comfortably inside the orbit of the planet Mercury. So here is something genuinely strange to hold. A thing as massive as 4 million suns, and yet its actual edge, the region it has sealed off from the universe, is smaller than the inner solar system. That is what extreme gravity does. It does not spread mass out. It crushes it inward, packs the unimaginable into the small. 4 million suns hidden inside a region you could tuck between the Sun and Mercury, sitting silent at the middle of the galaxy, pulling the whole bright wheel around itself for billions of years. We did not always know it was there, and the story of how we found it is worth a breath, because it shows how confident we can be about a thing we cannot see. For decades, astronomers watched the stars near the center of the galaxy, tracking their motion year after year, patient and meticulous. And they saw those stars doing something strange. They were whipping around an invisible point at tremendous speeds, some of them moving at thousands of kilometers per second, swinging around the center on tight, fast orbits as though caught by something enormous and unseen. There was nothing there to look at, no bright object at the focus of all those orbits. But the stars do not lie. Anything that can fling stars around that fast must be extraordinarily massive and extraordinarily compact. And when the numbers were worked out, only one kind of object fit, a black hole of about 4 million suns, dark and silent at the exact center of everything. We never saw it. We watched the stars dance around the empty place where it sat, and from their dance we knew its weight. Remember that method, because it is a cousin of the very trick we will use, later tonight, to weigh the monster 10 billion light-years away. The principle is always the same. You cannot see the dark thing, but you can watch what its gravity does to the things you can see, and from that you can weigh the darkness itself. Now, 4 million suns is already a number past easy picturing, but it is not yet the rung we are climbing toward, not even close, because our galaxy's black hole, as massive as it sounds, is on the smaller end of its kind. Out among the other galaxies there are black holes far larger. Consider the giant galaxy known as M87, a great ball of trillions of stars some 55 million light-years away. At its center sits a black hole of about 6.5 billion suns, not 4 million, but 6,500 million, well over 1,000 times more massive than our own. And this one is special, because it is the first black hole that humanity ever actually photographed. In the year 2019, a network of telescopes spread across the entire Earth worked together to capture an image of the glowing ring of hot gas around it, with the black, lightless circle of the event horizon at the center. For the first time, we looked directly at the shadow of one of these things and saw that the theory was right, that they are really out there, doing exactly what the mathematics said they would. Let that image settle, because it is our last familiar rung before the strangeness truly begins. A black hole of 6.5 billion suns, so large that its event horizon is bigger than our entire solar system, photographed and confirmed and hanging on the wall of human knowledge. That object is more massive than every black hole we have met so far on this climb put together, and we have a real picture of it. You would think, surely, that we have now reached the top, that a black hole bigger than the solar system and heavier than billions of stars must be about as large as these things get. It is a reasonable thought. It is the thought almost everyone has at this point. and it is wrong by a factor so large that the correction is the reason this video exists. Because there is something out there that makes even the giant of M87 look like a warm-up, and we are finally close enough to turn and face it. Part 4. A monster with no rival. We have arrived. After the long climb up from your own body, past the planet and the sun and the edge of the solar system, past the nearest star and the wheel of the galaxy, and the dark holes at the centres of galaxies, we are finally standing high enough on the ladder to meet the thing this whole night has been building toward. So let me bring it into view, slowly, the way you would turn to face something you had been warned about. In the direction of a faint constellation called the Hunting Dogs, far out in the night sky, there is a quasar, a blazing point of light from the core of a distant galaxy, and at the centre of that quasar sits a black hole whose mass, by the most widely quoted measurement, comes to about 66 billion times the mass of the Sun. I want to put that number directly beside the ones we just climbed past, because the comparison is the only way to feel it. The black hole at the centre of our own galaxy holds about 4 million suns. This one holds 66 billion. That is not a little larger. That is more than 10,000 times more massive than the black hole our entire Milky Way revolves around. And the giant of M87, the one we photographed, the one whose event horizon already dwarfs our solar system, holds 6.5 billion suns. Ton 618 holds roughly 10 times more than that. The largest black hole most people have ever heard of, the famous one, the photographed one, is 1/10 the size of the thing we are now looking at. Every rung we climbed was real, and every one of them is left far below. But the comparison I really want to hand you is a different one, because it does not involve other black holes at all, and it is the one that tends to genuinely land. Look up, on the clearest dark night you can remember, away from every city light, and let your eyes adjust until the sky fills with stars and the pale band of the Milky Way itself stretches overhead. Everything you can see up there, every single point of light, is a star in our galaxy, and the faint glowing band is the combined light of countless more too distant to separate. Our galaxy holds something like a few 100 billion stars in total, and their combined mass, all of them together, every star in the Milky Way, comes to perhaps 60 billion suns or so. Now hear the number for Ton 618 one more time. 66 billion suns. This single dark point, this one object, is more massive than every star in our galaxy combined. Stop and let that land properly, because it is one of the genuinely staggering facts in all of astronomy, and it deserves more than a passing nod. Take every star you have ever seen with your own eyes. Take every star you ever could see, on every clear night for the rest of your life, from every dark place on Earth. Then add to them all the hundreds of billions of stars you can never see, the ones hidden behind dust and distance, the entire population of our galaxy, the whole turning wheel of them that took light 100,000 years to cross. Gather all of that, every sun in the Milky Way, into one enormous total, and it would still not quite outweigh this single black hole in the constellation of the Hunting Dogs. One dark, silent, invisible point outweighs the entire galaxy of stars you live inside. I want to try the comparison from one more angle, because there is a version of it that sometimes succeeds where the galaxy version slides off. Think of the grains of sand on a beach, the image people always reach for when they want to say a number is huge. A large beach might hold somewhere in the range of 1 billion grains of sand, give or take. The whole shoreline you can see, the entire sweep of it from end to end, 1 billion grains. Now imagine 66 of those beaches, every grain of sand on 66 entire beaches, and let each grain stand for one sun, a furnace 1 million Earths could fall into. That is the count we are talking about. 66 billion suns is 66 beaches of suns, and every single grain is a star. And here is the part that breaks the picture even as you build it. You cannot actually hold 66 beaches of sand in your mind either. You can hold one beach, maybe, as a blur. 66 of them is already past the edge, just like the suns, just like everything tonight. Every road you take toward this number ends at the same cliff. You can walk up to the cliff by 100 different paths, through suns or beaches or galaxies, and every path delivers you to the identical place, the edge where the picture stops and only the word remains. That is not a flaw in any one comparison. It is the shape of the thing itself. This is the moment I told you to wait for back at the very beginning. This is the rung giving way. Because you heard that. You understood every word of it, and I would bet that no picture formed. There is no image your mind can build of one object outweighing a whole galaxy, because there is nothing in your experience, nothing on your private ruler of oceans and mountains, that the comparison can attach to. The fact is true. It is measured. It is as solid as anything in science, and it is at the same time completely unpicturable. The number and the size have come apart in your hands, exactly as I promised they would, and you are left holding a truth too large to see. And I want to be careful here, because there is a cheap version of this moment and an honest one. The cheap version just shouts the number at you and lets you feel small and overwhelmed, which is a kind of bullying dressed up as wonder. The honest version asks you to notice something gentler and stranger, that your inability to picture this is not ignorance. You're not failing to understand Ton 618. You understand it perfectly well. You know its mass, you know how it compares to the sun and the galaxy. You know it is real. What you cannot do is convert that understanding into a picture, and that is a different thing entirely. It is the discovery that knowing and imagining are two separate faculties, and that the universe is large enough to feed the first one long after it has starved the second. There is something almost tender in that, if you let yourself feel it. For your whole life, knowing a thing and being able to picture it have walked together, hand in hand, so closely that you never noticed they were two different things. A dog, a house, a city, a country. You know them, and you can see them, and the seeing and the knowing feel like one act. Ton 618 is the place where they finally let go of each other and walk apart, and you get to watch it happen inside your own head. The knowing goes on, the picturing stops, and in the space between them, if you are quiet, you can feel the actual size of the universe pressing in, not as a threat, but as the plain fact that reality was never required to stay small enough for you to hold. And here is a gentle thing to notice about that before we go on. You're not the first person to feel their mind give out at this exact spot. Every astronomer who has ever studied Ton 618 has felt it too. The people who measured its mass, who wrote the papers, who know these numbers far better than either of us, cannot picture 66 billion suns any better than you can. Knowing the number with great precision does not grant you the ability to see it. The expert and the newcomer stand at the very same cliff, because the cliff is not a matter of expertise. It is a feature of the human mind, the same in all of us. There is something quietly comforting in that. The failure of imagination you are feeling tonight is not ignorance, and it is not yours alone. It is the shared and permanent condition of every mind that has ever turned itself toward the largest things in the universe, the brilliant and the ordinary alike, all of us standing together at the edge of the same picture we cannot complete. We are, all of us, equally small beneath this, and there is a kind of fellowship in that smallness that I find more warming than any false claim to have grasped the ungraspable. Now, a fair and honest question is rising in you about now, and I do not want to skip past it, because skipping past it would be exactly the kind of empty wonder this channel refuses to traffic in. The question is this: how could anyone possibly know that? How do we have the nerve to put a number, 66 billion suns, on a black hole we cannot see, at the centre of a galaxy so far away its light has been travelling toward us for billions of years? It is one thing to weigh the sun, which is right there. It is another thing entirely to claim you have weighed an invisible object on the far side of the visible universe and gotten an answer you would stake your reputation on. That question deserves a full and careful answer, and we are going to give it one. But before we do, before we look at how we know, I want to do something even more unsettling than telling you the mass. I want to show you how big this thing actually is. Not its weight, but its sheer size, the actual width of the region it has sealed off from the rest of the universe. Because the mass is hard to picture. The size, strangely, is even harder, and it is waiting for us on the next rung. Part 5. The event horizon that swallows the solar system. We said earlier that a black hole's event horizon, its boundary, its point of no return, gets larger in exact step with its mass. The more massive the black hole, the wider the sphere it has sealed off from the universe. This is a clean and reliable rule, one of the few simple things about these objects, and it means that once we know Ton 618 weighs around 66 billion suns, we can work out exactly how large its horizon must be. So let us do that, and then let us go and stand at the edge of it, because the answer is where the size of this thing stops being a number and starts being a place. The event horizon of Ton 618, the sphere from which nothing can ever return, has a radius of roughly 1,300 times the distance from the Earth to the Sun. That distance, the Earth to Sun gap, is the basic measuring stick astronomers use for the solar system. Light crosses it in about 8 minutes, and we call it 1 astronomical unit. The radius of this black hole is about 1,300 of them, which means the full width of the thing straight across is something like 2,600 times the Earth-Sun distance. In plain kilometers, the event horizon stretches close to 400 billion kilometers from one side to the other. But kilometers at this scale are useless. The number is just more digits sliding off the glass. So let us not use kilometers. Let us use the solar system itself as our ruler and walk the size out step by step. Remember the climb we made earlier, out from the Sun to the edge of the planets. Remember that Neptune, the farthest major planet, the cold blue giant at the rim of the known worlds, orbits at 30 times the Earth-Sun distance, and that sunlight takes more than 4 hours to reach it. Neptune's orbit is, for almost everyone, the practical edge of the solar system, the boundary of the planetary realm. Now hold the size of that whole orbit in your mind, the entire disk of the planets, the full sweep from the Sun out to Neptune and back around. The event horizon of TON 618 is roughly 40 times wider than that. You could take our entire planetary solar system, the Sun and all 8 worlds and everything between them, and drop it into this black hole's horizon, and it would sit near the center like a small coin dropped into a stadium, with room for dozens more solar systems before you reach the edge. I want you to actually stand inside that picture, so let us go there together for a moment. Imagine you're floating at the very center, where the black hole's heart would be, and around you, close in, sits our whole familiar solar system. The Sun is a bright speck near you. The Earth's orbit is a tiny ring you could almost reach out and touch. Neptune's orbit, the edge of everything we call home, is a small circle not far out. And now you begin to travel outward, away from the center, toward the boundary of the event horizon, and you are moving at the speed of light itself, the fastest anything can move. You pass the orbit of Neptune in 4 hours, and then you keep going and going. The solar system shrinks behind you to a bright dot, and still the boundary is nowhere in sight. Hours pass, a day passes. You're moving at 300,000 kilometers every second, the absolute limit of reality, and the far side of this single black hole is still ahead of you. Days go by. It takes you about 2 weeks, traveling at the speed of light simply to cross from one side of the event horizon to the other. Hold that, because it is one of the most quietly devastating facts I know. Light is the fastest thing in existence. Light crosses the gap from the Sun to the Earth in 8 minutes. Light crosses the entire inner solar system in a matter of hours. Light needs only 100,000 years to traverse our whole galaxy of hundreds of billions of stars. And that same light, that same impossibly fast messenger, needs 2 full weeks just to make it across the width of this one object's shadow. The thing is so large that the universe's fastest traveler, the courier that carries every image and every signal and every scrap of information across all of space, would spend a fortnight in transit just getting from edge to edge. There is no engine, no spacecraft, no imaginable technology that crosses it faster, because nothing crosses anything faster than light, and light takes 2 weeks. Let me give you one more way to stand inside this size, because the light crossing time, staggering as it is, can still feel abstract. Think instead about a single beam of light setting out from one edge of the event horizon, aimed straight across at the far side, and think about everything that could happen back on Earth in the time it takes to arrive. The beam leaves. A person on Earth goes to sleep, wakes, lives a whole day, sleeps again. The beam is still in flight. They live through an entire week, the better part of a working week and a weekend, a full turn of ordinary life, and the beam is still crossing, still somewhere in the middle of that one black hole, having not yet reached the other side. It takes the better part of 2 weeks of human living before the light finally completes its single trip across this one object. And that object is not a galaxy, not a cluster of galaxies, not some sprawling structure of stars. It is one black hole. It is a single point of collapsed matter, and the dark sphere it has sealed off. And light, the fastest thing the universe permits, spends a fortnight inside it. We are so used to light being instantaneous, the thing that crosses our rooms and our streets and our whole planet faster than we can blink, that we forget it has a speed at all. This object remembers it for us. It is large enough to make the fastest thing in existence look slow. And here is the part that turns the screw one more time, the part that makes this size somehow worse than the mass. When you heard 66 billion suns, at least the word billion gave your mind something to push against, however hopelessly. But the size does not even give you that. Because everything I just described, the solar system as a coin at the centre, the 2-week crossing at light speed, describes a region of space that is, from the outside, completely black and completely empty looking. There is nothing to see, no surface, no glowing ball, no edge your eye could catch. It is a sphere of pure absence, 400 billion kilometres wide, defined entirely by the fact that anything which enters it can never leave. You're trying to picture the size of a hole in reality, and the hole does not even have the courtesy to look like anything. It is the largest single thing we have been discussing all night, and it is, in the most literal sense, nothing you can see. And yet that emptiness is not really empty, and this is the final twist of the size that I want you to carry. The event horizon is not a hollow shell with a small black hole rattling around inside it. The horizon is the black hole, or at least it is the boundary that the black hole's mass defines. All of those 66 billion suns are in there, their gravity reaching out to set the edge of this enormous sphere, sealing off a region 40 solar systems wide from the rest of reality. So when you imagine the event horizon, you're not imagining a container holding something. You're imagining the actual reach of a single object's gravity, the size of the shadow that 66 billion suns of crushed matter throws across space. The thing is exactly as big as it looks, and it looks like nothing, and both of those statements are true at the same time. We have spent the whole night climbing toward a size, and now that we have reached it, we discover that the size belongs to a region of pure darkness, a hole in the visible universe so large that the fastest thing in existence needs a fortnight to cross it. You cannot point a camera at it and capture it the way you would capture a planet or a star. You can only map the edge of where the light stops, and call that vacant 2-week wide circle of absence the largest single object we have ever measured. So let us take stock of where we are, because we have now climbed past the 2 hardest rungs. We know this object's mass, more than every star in our galaxy combined. We know its size, a region of darkness 40 times wider than the orbit of Neptune, 2 weeks across at the speed of light. And we have felt, I hope, both numbers come apart from any picture we could form of them. But a question has been waiting patiently through all of this, the one I promised we would not dodge. How does anyone know any of this? How do you measure the weight and the width of an invisible thing 10 billion light-years away? The answer is one of the most ingenious stories in all of science, and it begins, strangely enough, not with a black hole at all, but with the brightest light in the universe. Part 6. The brightest thing you cannot see. Here is the paradox we have to resolve before we can go any further. A black hole, by its very definition, gives off no light. It is the one kind of object in the universe that you fundamentally cannot see, because seeing requires light to reach your eye, and a black hole lets no light escape. And yet I have been telling you, all night, about a black hole 10 billion light-years away, a distance so enormous that the light reaching us now left before the Earth even existed. How can we possibly detect across that gulf the one kind of object that emits nothing at all? You should be suspicious of the whole story until this is answered, and the answer is the key that unlocks everything else. The resolution is that we do not see the black hole. We see what is happening to the matter around it as that matter falls in, and what is happening to it is the most violent light show in the universe. Ton 618 is not a quiet, dormant black hole sitting alone in the dark. It is a feeding one. Around it swirls an enormous disk of gas, the shredded remains of stars and clouds that wandered too close, and that gas does not fall straight in. It spirals, the way water spirals around a drain, going faster and faster as it draws nearer the centre. And as it spirals, the gas is squeezed and sheared and rubbed against itself with such ferocity that it heats up to temperatures of hundreds of thousands or millions of degrees until the whole disk blazes. It pours out light across every colour and far beyond, a furnace fed by gravity, glowing white-hot in the final hours before the matter tips over the edge of the event horizon and vanishes from the universe forever. This blazing disk of doomed, infalling gas is what we call a quasar, and Ton 618 is one of the most luminous quasars ever found. I want to give you the number, even knowing it will slide off the way the others did because the comparison is worth it. The quasar at the centre of TON 618 shines with the light of roughly 140 trillion suns. Not billion this time, trillion. It is brighter than our entire Milky Way galaxy, brighter than hundreds of billions of stars combined, all of that brilliance pouring out of a region not much bigger than our solar system. It is, in fact, this staggering brightness that lets us see it at all across 10 billion light-years. The black hole is invisible, but the death cry of the matter falling into it is one of the brightest beacons in the known universe, and that beacon is what reaches our telescopes. I want to slow down on the temperatures involved, because they are part of why the brightness is so extreme. As the gas spirals inward, faster and faster, it does not glide smoothly. It grinds against itself, layer rubbing against layer at different speeds, and that friction heats it ferociously. The innermost regions of the disk, just outside the point of no return, can reach temperatures of hundreds of thousands of degrees in places climbing toward millions. At those temperatures, matter does not glow with a gentle warmth like a coal or a candle. It blazes across the whole range of light and far past it, pouring out not just visible colour but ultraviolet and X-rays, the high, fierce kinds of light that only the most violent places in the universe produce. So when we say TON 618 shines with the light of 140 trillion suns, we are describing a torrent of radiation born from gas being tortured by gravity in the final hours of its existence, screaming light across the spectrum as it falls. And every photon of that light carries a small piece of information about the conditions that made it, which is precisely why, by catching and studying that light, we can reconstruct so much about an object we will never visit. The brightness is not just a beacon that says, "Here I am." It is a message, dense with detail, written in the dying light of falling matter, and learning to read it is one of the quiet triumphs of modern astronomy. There is a strange and beautiful irony folded into this, and I do not want it to pass you by. The most luminous objects in the entire universe, the quasars, are powered by the darkest objects in the entire universe, the black holes. The thing that emits the most light is driven by the thing that emits none. The brilliance is not in spite of the black hole, it is because of it. Only an object with gravity this overwhelming can pull matter in hard enough and fast enough to heat it to such temperatures. So the very property that makes a black hole invisible, its monstrous gravity, is the same property that lights up the gas around it, like a beacon visible across the whole observable universe. The darkness and the light are two faces of the same thing. Now, we have talked about the engines of quasars before on this channel, the way gravity turns falling matter into radiation with an efficiency that puts even the nuclear fire of stars to shame, so I will not retrace all of that ground tonight. What matters for our purposes is simpler and more pointed. The light from the quasar is not just a beacon telling us the black hole is there. It is also encoded within it a message about how massive the black hole is. The light carries, woven into its colours, a record of how fast the gas around the black hole is moving, and the speed of that gas is set by the strength of the gravity holding it, and the strength of that gravity is set by the mass. So if you can read the light carefully enough, if you can decode the speed of the swirling gas from the quality of the glow, you can weigh the invisible thing at the centre. That is the trick. That is how you put a number on a shadow, and the way it is actually done is so clever and so unexpected that it deserves its own telling. Before we get to that, though, I want to pause on the distance itself because it is part of the size of this thing in a way that is easy to skip past. The light from TON 618 has been travelling toward us for about 10.5 billion years. Think about what that means. When this light left the quasar, the sun did not exist. The Earth did not exist. There was no solar system at all, no planets, no life, nothing. The light set out across the universe when the cosmos was less than a third of its current age, and it has been crossing empty space ever since for 10.5 billion years, through the entire formation of our sun and our world and every living thing that has ever been, and it arrives now, tonight, to fall into a telescope built by creatures who are not even a possibility when it began its journey. You're not looking at TON 618 as it is. You're looking at a ghost, an image of how it was billions of years before there was anyone here to look. This is true of everything in the night sky, of course, but the distances are usually small enough that we forget it. The sun you see is 8 minutes old. The nearest star is 4 years old by the time its light reaches you. But TON 618 is a different order of thing entirely. Its light is 10.5 billion years old, which means we're not looking across space so much as down a well of time, seeing the object as it existed in an era when the universe itself was young and our world was not even a possibility. And this raises a strange and almost dizzying point that we'll return to at the very end of the night. We have been speaking of Ton 618 in the present tense, calling it the largest, the brightest, the most massive. But there is no present tense available to us for an object this far away. We can only ever see its past. What it is doing right now, in the universe's actual present, we have no way to observe and will not for another 10.5 billion years. The monster we are describing, the blazing quasar, may have changed beyond recognition in all the time its light has been travelling toward us. We are reading a letter that took 10.5 billion years to arrive, describing a sender who has lived an entire cosmic lifetime since they sealed the envelope, and that too is part of why this object breaks the imagination so completely. It is not only too massive to picture and too large to picture. It is also too far away and too far back in time for the words now or there to really mean anything. When we say Ton 618 is 66 billion suns, we are describing how it was 10.5 billion years ago, and we will come back near the end of tonight to the strange question of what it might be now, in a present we can never actually observe. But first we owe you the answer to the question that has been hanging over everything. We have claimed to weigh an invisible object on the far side of the universe. It is time to show you exactly how that impossible-sounding measurement is actually made, and to meet the quiet, almost accidental way this monster was first found at all. Part 7. How you weigh a shadow. The story of how we came to know Ton 618 does not begin with a triumphant discovery or a banner headline. It begins with a faint smudge on a photographic plate and a complete misunderstanding of what it was. Travel back to the year 1957 to an observatory at a place called Tonantzintla in Mexico, where astronomers were carrying out a careful survey of the sky, hunting for faint blue stars that lay far from the crowded band of the Milky Way. Night after night they pointed their telescope upward and let the light of the heavens fall onto large glass photographic plates, and then they developed those plates in the darkroom and pored over them, cataloguing every point of light, giving each one a number. Picture that darkroom for a moment. Picture the plate emerging slowly into focus under the developing chemicals, a black field scattered with thousands of tiny dots, each one a star, or so they believed. Among those thousands of dots, in the region of the constellation of the hunting dogs, was one faint, slightly violet point of light, no brighter and no more remarkable than its neighbours. An astronomer's hand recorded it, gave it a catalogue number, the 618th entry in their list, and moved on to the next dot. Ton 618. That was the entire event. No alarm, no excitement, no sense that anything unusual had happened. They had photographed what they took to be a dim blue star within our own galaxy, filed it away under a number, and turned to the rest of the sky. And they were completely wrong about what it was, in the most spectacular way imaginable. The faint violet dot was not a star. It was not in our galaxy at all. It was the blazing core of a galaxy near the edge of the visible universe, 10.5 billion light-years away, its light so brilliant that even across that unthinkable gulf it still registered as a visible point on a photographic plate. The thing they had casually catalogued as star number 618 was, in truth, one of the most luminous and most massive objects anywhere in creation. But nobody knew that yet, because nobody yet understood what they were looking at. The tools to understand it did not arrive until years later. This is one of my favourite kinds of moment in the history of science, and I want to let it breathe, because it is so unlike the way we imagine discovery happening. There was no genius staring at the plate and gasping. There was no eureka. There was a tired astronomer in a dark room late at night, doing patient and unglamorous work, who looked directly at one of the largest objects in the known universe and saw nothing special at all. The monster was hiding in plain sight, disguised as the most ordinary thing in the sky, a faint dot among thousands. It would take the better part of a decade and a revolution in how we understood these strange points of light before anyone realized that some of those faint blue dots were not stars, but the distant, furious centers of galaxies, the things we now call quasars. And Ton 618 turned out to be among the most extreme of them all. The revolution itself is worth understanding because it changed the whole sky. For years, these star-like points puzzled astronomers because they had spectra that made no sense, sets of spectral lines that did not match any known element in any known arrangement. They were called quasi-stellar objects, things that looked like stars but clearly were not, and the name was eventually shortened to quasars. The breakthrough came when someone realized that the lines did match familiar elements after all, but shifted dramatically toward the red end of the spectrum, stretched by an enormous amount. And that stretch could mean only one thing. These objects were rushing away from us at a large fraction of the speed of light, carried by the expansion of the universe itself, which meant they were not nearby stars at all, but objects unthinkably far away. For a thing that distant to still appear as a visible point of light, it had to be staggeringly, almost impossibly luminous, far brighter than any ordinary galaxy. The faint dots were revealed to be the most luminous objects in the universe, blazing across billions of light years, and once astronomers understood that, they went back through their old catalogues with new eyes. Among the entries they re-examined was a certain violet point recorded at Tonnant-Zintler, listed long ago as star number 618, and they found that it was not a star but one of the brightest and most massive quasars ever discovered, hiding all that time inside the most ordinary-looking entry in an old survey. So how did the understanding finally come, and how do we get from a dot on a plate to the claim of 66 billion suns? The key is something called the spectrum of the light. When you take the light from a distant object and spread it out, the way a prism spreads sunlight into a rainbow, you do not get a smooth, featureless band of colour. You get a band crossed by sharp lines, bright lines where certain colours are unusually strong, and dark lines where certain colours are missing. Those lines are produced by specific elements, hydrogen, helium, and the rest, each of which emits and absorbs light only at its own exact characteristic colours. The pattern of lines is a fingerprint, and it tells you what the object is made of, how fast it is moving toward or away from you, and crucially for our story, how fast the gas around it is swirling. That last point is the whole trick, so let me slow down on it. Around Ton 618's black hole spirals that enormous disk of hot gas we talked about, the gas whose glow we see as the quasar. The gas closest to the black hole is whipping around at tremendous speeds, dragged along by the ferocious gravity. Now, when glowing gas moves, the lines in its spectrum shift and spread. Gas coming toward us has its lines nudged toward the blue end of the spectrum. Gas moving away has its lines nudged toward the red. In the disk around the black hole, some of the gas is always coming toward us, and some is always moving away, all at once, because it is going around in a circle. The result is that the spectral lines do not stay sharp and narrow. They get smeared out, broadened, spread into wide blurry bands, and the faster the gas is moving, the wider those lines are smeared. Here is the elegant part. The speed of that swirling gas is set by the gravity holding it in orbit, and the gravity is set by the mass of the black hole. A more massive black hole grips its gas more tightly, and whirls it faster, which smears the spectral lines wider. So by measuring exactly how wide the lines are smeared, astronomers can work backward to the speed of the gas, and from the speed of the gas to the strength of the gravity, and from the strength of the gravity to the mass of the invisible object at the centre. It is a chain of reasoning that lets you weigh something you cannot see on the far side of the universe, using nothing but the blurriness of lines in its light. When this was done for Ton 618, in a careful analysis in the year 2004, the lines turned out to be among the widest ever measured in any quasar, hinting at gas moving at thousands of kilometres every second. And the mass those monstrous line widths implied was the number that made the object famous, around 66 billion suns. It is worth pausing on just how wide those lines really were, because the width is the whole measurement, and in Ton 618 it was record-setting. When astronomers compared this object against a whole sample of other quasars, its emission lines were among the broadest any of them had ever seen, smeared out by gas moving at speeds of thousands of kilometres per second around the central object. Picture what that means physically. The gas closest in, the gas whose light we are reading, is being whirled around the black hole so fast that in a single second it covers a distance that would carry it most of the way across a continent. And it is doing this not in a straight line but in a tight circle, held in that furious orbit by gravity alone. The only thing that can grip gas hard enough to swing it that fast, in a region small enough to produce the light we see, is an enormous concentration of mass, and the width of the line tells us, almost directly, how enormous. There is something beautifully direct about it once you see it clearly. We are not guessing. We are reading the speed of the gas straight off the blur of its light, the way you might read the speed of a passing car off the smear it leaves in a photograph, and converting that speed into the weight of the unseen thing doing the pulling. The lines of Ton 618 are among the most smeared in the known universe, and that is exactly why its black hole is among the most massive we have ever weighed. Think about what that chain of reasoning really represents. A tired astronomer in 1957 photographed a dot and called it a star. Decades later, others spread that dot's light into a spectrum, measured the precise width of a single smeared line of glowing hydrogen, and from that width alone deduced that the dot was a black hole more massive than our entire galaxy of stars, 10.5 billion light-years away. We never went there. We never could. We held no part of it in our hands. We weighed a shadow from across the visible universe by reading the blur in a line of light, and the answer came back larger than imagination. That is not a guess shouted into the dark. It is one of the most disciplined and astonishing measurements our species has ever made, and yet, and this is where intellectual honesty has to enter the room, it is still a measurement made across an almost impossible distance by an indirect method, and that means it comes with an uncertainty we're obliged to talk about. Because the famous number, the 66 billion, may not be quite right. Part 8. The number that might be wrong. I have been careful all night to keep saying the same cautious phrase, and you may have noticed it. The most widely quoted measurement. I have used that phrase deliberately, because this channel does not deal in false certainty, and the truth is that the mass of Ton 618 is not settled to the last digit. The famous figure of 66 billion suns comes from that 2004 analysis of the smeared spectral lines. But measuring the mass of an invisible object 10.5 billion light-years away by reading the blur in its light is hard, genuinely hard, and different methods and different assumptions can give different answers. And in the year 2019, a fresh analysis using improved techniques revised the figure downward to something closer to 40 billion suns. Now, I could have hidden that from you. A lot of tellings of this story do. The 66 billion figure is the dramatic one, the famous one, the one that makes for the best thumbnail, and quietly dropping the revision would have made tonight's monster a little more monstrous. But I think you deserve better than that, and I think the truth here is actually more interesting than the tidy version, not less. So let me say it plainly. The mass of Ton 618 is not known to perfect precision. The headline number is around 66 billion suns. A careful reanalysis suggests it may be closer to 40 billion. The real value is somewhere in that range, and the uncertainty is large because the measurement is being stretched across an almost unimaginable distance, using an indirect method that was never going to give a perfectly clean answer. And now, I want you to watch what happens to the wonder when we admit that, because something genuinely surprising occurs. You might expect that cutting the number from 66 billion down toward 40 billion would deflate the whole thing, would shrink the monster, would take some of the air out of the wonder. Sit with the two numbers for a moment, though. 66 billion suns, 40 billion suns. Try to feel the difference between them. Try to picture 40 billion of something, and then picture 66 billion of the same thing, and feel which one is larger. You cannot do it. There is no picture of either. The mind that could not hold 66 billion cannot hold 40 billion any better, because both numbers are equally and completely past the edge of what imagination can build. The correction is real, and it matters to astronomers, and it changes the object's exact place in the rankings of cosmic giants. But it changes nothing at all about the experience we have been having tonight, because you were never picturing the number in the first place. You were holding a word. This is the deepest version of the thread I asked you to hold from the very beginning. A number is not the same as a size. We have now proven it in the hardest possible way. We took the central fact of the whole video, the mass, and we changed it. We cut it down by more than a third, and your inability to picture it did not budge by a hair. That is extraordinary if you let yourself notice it. It means that somewhere on the climb up the ladder of scale, the numbers stopped connecting to anything your mind could see, and once they crossed that line, their exact value became irrelevant to the feeling. 40 billion, 66 billion, it is all the same on the far side of imagination. They are all just the word enormous, wearing different digits as a costume. There is a lesson hiding in this that reaches far past Ton 618, and I think it is one of the most useful things astronomy can teach. We live in a moment that loves precise numbers. that treats a figure with many digits as more trustworthy than a figure with few, and for things at human scale that instinct serves as well. But at the outer edges of the universe, precision and meaning do not always travel together. A number can be uncertain by tens of billions of suns and still tell you something absolutely true and absolutely staggering, that here is an object more massive than a galaxy of stars. The uncertainty does not erase the wonder, it just marks the honest edge of our reach. And there is a kind of maturity in being able to hold both at once, to say with full confidence this thing is unimaginably massive, and in the same breath to say, and we are not sure of its weight to better than a factor of 1.5. Those two statements do not fight each other. They are both true, and together they are more honest and stranger than either alone. The people who study these objects live comfortably in that space, holding firm knowledge and real uncertainty in the same hand, and I think learning to do the same is part of what it means to look at the universe like an adult, rather than a child demanding a single tidy answer. TON 618 offers us that lesson in its purest form, because it is at once one of the best-known monsters in the sky, and an object whose exact weight we may never pin down. There is a humility in this that I find genuinely moving, and I want to share it with you rather than just point at it. We are a species that learn to weigh the invisible cause of distant galaxies by reading the blur in lines of ancient light, and even after all that ingenuity, the best we can honestly say is that this thing is somewhere between 40 and 66 billion times the mass of our Sun. The error bar on that measurement, the part we are unsure about, is itself around 26 billion suns. Let that settle. The amount we are uncertain about, the wobble in our own answer, is more than 400 times the mass of the entire black hole at the centre of our galaxy. Our uncertainty alone is larger than almost anything most people would ever call unimaginably big. When the things you're merely unsure about dwarf the things you thought were the limit of large, you understand that you have wandered very far indeed from the territory the human mind was shaped to walk. And yet, notice, this is not a story about ignorance. It is a story about the particular shape of knowledge at the outer edges of what can be known. We do not throw up our hands and say we know nothing about TON 618. We know an enormous amount. We know it is a quasar. We know it is 10.5 billion light-years away. We know its light is one of the brightest in the universe. We know its mass to within a factor that, while large in absolute terms, is small compared to the thing itself. We're arguing about whether it is 40 or 66 billion, not about whether it is 40 or 40 million. This is a distinction worth holding on to because it is easy to hear the word uncertain and imagine that scientists are simply guessing. They are not. There is a difference between not knowing something at all and knowing it to within a certain range, and almost everything we know about the distant universe lives in that second category. We do not know TON 618's mass to the last digit, but we know it is not 4 billion, and we know it is not 600 billion. We have it pinned to a band, a window of possible values, and the whole window sits in territory that is unimaginable by any measure. The uncertainty is real, and it is honest, but it is bounded, and the bounds themselves tell a staggering story. Even the smallest value anyone seriously proposes for this object would still make it one of the most massive black holes ever found, still more massive than most of an entire galaxy's worth of stars. So when you carry this number away with you, do not carry it as a shaky guess. Carry it as a careful measurement with honest edges, a thing we know well enough to be amazed by, and not so perfectly that we would pretend to a precision we do not have. That is what real knowledge of the far universe looks like. Not a single confident digit, but a window onto something true, with the honest blur left in. We have pinned this monster down with real precision. We have simply also been honest that the last digits are blurry, and in being honest we have stumbled onto something profound. That past a certain scale, precision and imagination part ways completely, and the exact number stops mattering to the only faculty that was ever going to fail anyway. So let us carry both things forward together, the knowledge and the humility, because we are going to need both for the questions that come next. We have met the monster. We have felt its mass and its size break our imagination, and we have watched that break survive even when we corrected the number. But knowing how big it is only sharpens the next question, the one any curious mind arrives at the moment the shock wears off. How does a thing like this come to exist at all? How do you build a black hole more massive than a galaxy of stars, and build it so early in the history of the universe that its light is older than the sun? because that, it turns out, is a genuine and unsolved puzzle, and it is one of the few places tonight where even the astronomers will tell you honestly that they are not entirely sure. Part 9. How do you build something this big? Every black hole has to start somewhere, and the somewhere is always smaller than what it becomes. Black holes are not born enormous. The ordinary ones, the ones scattered through every galaxy, form when a massive star reaches the end of its life and collapses, crushing a few times the mass of the Sun into a point. That is the seed, the starting size, a black hole of perhaps 10 or 20 or 30 suns. And from that seed, a black hole can grow in two main ways. It can swallow matter, pulling in gas and dust and the occasional unlucky star, adding their mass to its own. And it can merge with other black holes, two of them spiraling together and combining into one larger object. Growth by eating and growth by merging. Those are the tools the universe has to work with, and the puzzle of TON 618 is that neither of them, on its own, seems quite fast enough to explain it. Consider the time problem first, because it is the sharpest part of the difficulty. The light we see from TON 618 left it 10.5 billion years ago, when the universe was only about 3 billion years old. So whatever process built this 66 billion sun monster had to accomplish the entire job in less than 3 billion years, starting from an ordinary stellar seed of a few dozen suns. It had to multiply the seed's mass by a factor of something like 1 billion, in a stretch of time shorter than the age the universe had reached. That is a furious rate of growth, and the trouble is that there is a natural speed limit on how fast a black hole can eat, and that speed limit, by the simplest reckoning, is not fast enough to get you from a stellar seed to a galaxy-sized monster in the time available. The speed limit comes from the very brilliance we talked about earlier. As a black hole feeds, the infalling gas heats up and blazes, and that blaze pushes outward. Light itself exerts a pressure, gentle but real, and when the gas around a black hole glows brightly enough, the outward push of that radiation starts to shove away the very gas the black hole is trying to swallow. The brighter the feeding, the harder the pushback, until the black hole effectively chokes on its own light, blowing away its next meal before it can eat it. This sets a maximum sustainable feeding rate, a ceiling on how fast a black hole of a given mass can grow, and if you start with a small stellar seed and feed it at that maximum rate continuously, you simply cannot reach 66 billion suns in under 3 billion years. The arithmetic does not close. The monster should not have had time to grow. Let me make the time pressure vivid, because the numbers alone can hide how tight the schedule really is. Imagine you are trying to grow a black hole the ordinary way, by steady feeding at the fastest rate the radiation limit allows. Even at that maximum, a black hole roughly doubles its mass only over a span of tens of millions of years. That sounds quick, and it is, but think about how many doublings you need. To get from a stellar seed of about 30 suns up to 66 billion, you have to double the mass again and again and again, more than 30 times over, and each doubling takes tens of millions of years, and you cannot pause, not once, not for a moment. The black hole must feed at full throttle continuously for essentially the entire first few billion years of the universe, never starving, never stalling, never running short of gas, in order to just barely arrive at the mass we observe by the time the light left it. And real black holes do not feed so perfectly. Their fuel comes in fits and starts. Sometimes the gas runs out and the feeding stops for long stretches. Every pause, every interruption, every dry spell pushes the finish line further out of reach. So the puzzle is not merely that the growth is fast, it is that the growth has to be both maximal and uninterrupted across almost the entire early history of the cosmos, with no margin for the ordinary stops and starts that real feeding always involves. Something about the simple story is missing, and that missing piece is one of the questions our newest telescopes are working hardest to answer. So how did it? This is where astronomers reach honestly for ideas that are not yet settled, and I will lay out the leading ones, all of them labelled clearly as the open speculation they are. One possibility is that the seeds were not ordinary stellar black holes at all, but something much larger from the start. In the very early universe, before stars as we know them had formed, there may have been enormous clouds of pristine gas that collapsed directly into black holes of tens of thousands, or even 100,000 suns, skipping the star stage entirely. A seed that large would have a colossal head start, and growing from 100,000 suns to 66 billion is a far easier race to run than starting from 30. These are called direct collapse seeds, and whether they really existed is one of the live questions in cosmology. A second possibility is that the feeding sometimes broke its own speed limit. The radiation pressure ceiling we just described assumes the gas is falling tidally, in a smooth and balanced way. But the early universe was a messier, denser, more chaotic place, with gas piled thick around young galaxies, and under the right violent conditions a black hole might gorge faster than the ordinary limit allows, swallowing matter in great choking gulps that briefly overwhelm the outward push of its own light. Bursts of this super-fast feeding, repeated over and over in a gas-rich young galaxy, could pile on mass far quicker than the gentle, steady rate. And a third possibility, almost certainly part of the answer, is mergers. The early universe was more crowded, galaxies colliding and combining far more often than they do today, and every time two galaxies merged, their central black holes would eventually find each other and merge too. Stack enough of these collisions together, each one combining two large black holes into a larger one, and you have another powerful engine of growth. The honest truth is that we do not know which of these did the work for Ton 618, and the real answer is probably all of them at once. A heavy seed, episodes of furious feeding, and a history of mergers combining over the first few billion years of cosmic time to assemble something that, by the simple arithmetic, should not have had time to exist. This is not a small or obscure problem. It is one of the genuine frontiers of the science, sharpened in recent years as our newest telescopes have found more and more of these enormous early black holes blazing as quasars when the universe was startlingly young, all of them posing the same stubborn question. They are too big, too soon. The models bend to accommodate them, and Ton 618, sitting near the very top of the mass scale and shining from a time when the cosmos was barely getting started, is one of the most extreme versions of the puzzle we have. I find something wonderful in the fact that the largest thing we have found is also, partly, a thing we cannot fully explain. It would be a tidier universe if the biggest object came with the clearest story, if sheer size meant sheer certainty. Instead, the monster keeps a secret. We can weigh it, we can size it, we can map the blur in its ancient light, and still we cannot say for certain how it grew so large so fast. The knowing and the not knowing sit side by side, the way the knowing and the imagining did, two faculties reaching toward the same object and each falling a little short in its own way, and the puzzle has a sharper edge still, one we have not yet touched. We have been asking how Ton 618 got so big. But there is a stranger question lurking underneath it. Is there a limit? Is there a size past which even the universe cannot build? A ceiling on how large a single black hole is allowed to become? And the answer to that question may mean that Ton 618, monstrous as it is not even the end of the climb. Part 10. Is there a ceiling? It would be a comfort in a way to learn that Ton 618 is the largest black hole there can possibly be. The final rung, the top of the ladder, the place where the climb simply stops because it can go no higher. The mind reaches for that kind of resolution. We have come so far up, surely this must be the summit. But the universe rarely offers that comfort, and the honest answer to whether there is a ceiling on black hole size is stranger and more open than a simple yes or no. There does seem to be a kind of limit, but Ton 618 is sitting right at the edge of it, and there are objects out there that may be larger still. Let us start with the idea of a natural ceiling, because there is real physics behind it. Remember that black holes grow mainly by feeding, by pulling in that disk of glowing gas. But the disk itself cannot be arbitrarily large or feed arbitrarily fast forever. As a black hole grows more and more massive, the conditions in the disk around it change, and at a certain point the disk can no longer hold itself together in the orderly, infalling spiral that feeds the black hole. The gas, instead of streaming inward, tends to fragment and collapse into stars rather than falling in. When that happens, the feeding effectively shuts off. The black hole stops being able to grow by accretion, because its food keeps turning into stars before it can be eaten. By this reasoning, there is a rough upper limit to how massive a black hole can become through ordinary feeding, and that limit works out to somewhere around 50 billion suns. I find it genuinely poetic that a black hole could starve in this particular way, and it is worth dwelling on for a moment because it is so counterintuitive. We think of these objects as endlessly hungry, as the ultimate devourers, things that pull in everything and never stop, and yet the very physics that lets them feed also, at the largest scales, takes the food away. As the black hole grows, the orderly disk that supplies it grows too, spreading outward, and at the outer reaches of a sufficiently enormous disk. The gas becomes so spread out and so cool that its own gravity wins out over the pull toward the centre. Instead of streaming inward to be eaten, it clumps and collapses into stars, locking itself away in objects the black hole cannot easily swallow. The monster, in effect, sets its own table, and then watches its meal turn into something it can no longer reach. Past a certain size, the bigger it gets, the harder it becomes to get any bigger, until it stalls out near that ceiling of around 50 billion suns. So there may be a natural largest size for a black hole grown the ordinary way, not because the universe forbids more mass in principle, but because the feeding mechanism quietly defeats itself. And Ton 618, sitting right at that ceiling, is the universe showing us almost exactly how big the ordinary process can build before it runs out of room. Look at where that puts Ton 618. The proposed natural ceiling for growth by feeding is around 50 billion suns. Ton 618, by the famous measurement, is around 66 billion. It is sitting at, or even slightly above, the very limit beyond which the simple theory says a black hole should no longer be able to feed itself. That is part of what makes it such a fascinating object to astronomers. It is not just large, it is pressed up against a possible wall, a thing that has grown about as massive as the universe seems to know how to make by the ordinary route, and perhaps nudged past it by the mergers and the early head start we talked about. It is a record holder that is also a test case, an object that probes the question of how big is too big. And here is where the climb refuses to end neatly, because Ton 618, for all its fame, may not actually be the single largest black hole we know of. There are other contenders, other monsters near the top of the scale. There is a black hole in a galaxy cluster called Abel 85, an object of around 40 billion suns, comparable to the revised lower estimate for Ton 618 itself. And there is a more extreme candidate still, a black hole associated with a distant cluster called the Phoenix cluster, an object sometimes estimated as high as 100 billion suns. 100 billion. If that estimate holds, it would be substantially more massive even than Ton 618, at its famous 66 billion, sitting far out past the proposed feeding limit, a genuine candidate for the most massive black hole humanity has ever identified. And there is reason to think this one, the Phoenix monster, may be brushing against the practical top of the scale, the largest a black hole can realistically become by any route the universe has available, which would make it not just the biggest we have found, but close to the biggest there can be. Whether that title belongs to it, or to Ton 618, or to some unmeasured giant still hiding in the dark, is a question the next generation of telescopes will keep refining for decades to come. So which one is the biggest? The honest answer is that it depends on which measurements you trust, and the rankings shift as the estimates are refined, because all of these masses carry the same large uncertainties we discussed for Ton 618. They are all measured indirectly, across enormous distances, with methods that give ranges rather than exact figures. Ton 618 has long held the popular crown, the one that shows up in every list of the largest black holes, partly because of that dramatic 66 billion figure, and partly because it was one of the first of these true giants to become well known. But whether it is truly the single most massive, or whether that title belongs to the Phoenix Cluster's monster, or to something not yet measured, is genuinely unsettled. The crown is held loosely. I want you to feel what that does to the climb we have been making, because it is the cruelest and most wonderful twist of the whole night. We spent all this time ascending the ladder, rung by rung, building toward Ton 618 as the summit, the thing too large to imagine. And now, having finally reached it, having felt our imagination break against it, we discover that it might not even be the top. There may be a black hole half again as massive in the Phoenix cluster. There are almost certainly others, out in the dark, that we have not yet found or measured, because we can only see the ones that happen to be blazing as quasars and pointing their brilliance our way. The quiet ones, the dormant giants sitting dark at the centres of distant galaxies, give off no beacon, and we have no easy way to weigh them. The largest black hole we have found is emphatically not a claim about the largest black hole there is. It is only a claim about the largest one we have so far managed to catch in the act of feeding. This is the part where the ground drops out one final time. You thought, reasonably, that the summit was the summit. And the universe answers gently and without malice that there is no summit you can be sure of, that the ladder continues up past the highest rung you can see into a darkness you cannot survey, and that somewhere up there, unmeasured and perhaps unmeasurable, hang objects even larger than the one that already broke your imagination. The thing too big to picture has bigger siblings. The number too large to hold has larger cousins. And we have met only the ones that happen to light a fire bright enough to see across 10 billion years. There is a temptation, facing all this, to feel a kind of despair, as if the universe were taunting us with sizes we can never grasp. But I want to offer you the opposite feeling, because I think it is the truer one. The fact that the ladder continues past where we can see is not a wall slammed in our faces. It is a door left open. It means the project of understanding the universe is not finished and never will be, that there is always another rung, always something larger and stranger waiting in the dark for the next telescope, the next clever measurement, the next patient astronomer in the next quiet observatory. Ton 618 is not the end of wonder. It is a marker we planted partway up a ladder that has no visible top, and the climb goes on. But before we look outward to what else might be up there, I want to do the opposite. I want to look inward into Ton 618 itself, past the boundary we have been standing at the edge of all night. Because we have talked endlessly about how big the outside of this thing is, we have not yet asked what waits at the centre. Part 11. What waits at the centre? All night we have stood at the edge of the event horizon, that boundary 2,600 times the Earth-Sun distance across, and treated it as the object. But the event horizon is not the thing itself. It is only the boundary, the line marking where escape becomes impossible. The horizon is not a surface or a wall. It is more like a coastline drawn on the sea, a place where a rule changes rather than a place where matter sits. So a natural question, perhaps the most natural one of all, has been waiting unasked. If the horizon is just a boundary, then what is inside it? What is at the centre of this enormous dark sphere? What in the end actually is a black hole underneath the line that hides it? And here we arrive at one of the most honest and unsettling admissions in all of physics. We do not fully know, not because we have not looked, but because the question reaches past the edge of where our best theory of gravity can follow. Our understanding of gravity, the framework Einstein gave us, describes the universe with extraordinary accuracy almost everywhere we point it. But when we use it to ask what happens at the very centre of a black hole, the equations stop giving sensible answers. They predict that all the matter that ever fell in, the 66 billion suns worth of mass, is crushed down into a single point of zero size and therefore infinite density, a point where space and time themselves curve infinitely sharply. We call this point the singularity, and the truth is that the word is less a description than a confession. The singularity is the place where our mathematics throws up its hands. It is the symbol we write where the theory admits it can no longer tell us what is happening. Most physicists do not believe the singularity is literally real, and that distinction matters, so let me be careful with it. When a theory predicts an infinity, the lesson of history is almost always that the theory is incomplete, not that nature truly contains an infinite quantity. Infinities are signposts, and the sign they hold up reads your description has broken down here. Find a better one. The centre of a black hole is widely thought to be exactly such a place, not a genuine point of infinite density, but a region where the gravity is so extreme and the scales so small that our current physics and the physics of the very tiny, the quantum world, would both have to apply at once, and we do not yet know how to make those two great descriptions of reality speak to each other. That unfinished marriage, the long search for a theory that unites gravity with the quantum, is one of the central unsolved problems in all of science, and the centre of a black hole is one of the few places in the universe where its absence really bites. So when I say we do not know what is at the centre of Ton 618, I do not mean we have no ideas. I mean that the honest answer requires a theory we have not yet built, and that the largest object we have ever found stands guard over a question that has defeated the finest minds of the last century. The monster keeps its deepest secret not behind its distance or its darkness, but behind the edge of human physics itself. This is a remarkable thing for a scientific theory to do, and I do not want it to slip past as just another fact. We have talked on this channel before about how the very best theory of gravity we possess contains, hidden inside it, the seeds of its own breakdown, points where it predicts infinities, and infinities are nature's way of saying that a theory has been pushed past its limits. The centre of a black hole is exactly such a place. It is not that we have an answer, and it is strange. It is that the question itself takes us to the one location in the universe where our deepest physics simply stops, where the map runs out and the edge of the parchment reads, in effect, here our knowledge ends. The largest object we have found, whose outside already broke your imagination, has at its very centre a place that breaks our science. So let us do the only thing we honestly can. Let us travel inward in our minds, knowing the journey ends at a question rather than an answer, and feel the strangeness of the descent. Imagine crossing the event horizon of Ton 618, slipping over that boundary 2 weeks wide at the speed of light. Nothing dramatic marks the crossing. There is no wall, no barrier, no flash. You might not even notice the moment you passed the line beyond which return became impossible. But everything has changed. Outside the horizon, you could always, in principle, turn and leave. Inside it, every possible direction you could travel, every path your engines could take leads inward toward the centre. The geometry of space has tilted so completely that the centre is no longer a place you can avoid by steering away from it. It has become something more like a moment in your future, as unavoidable as next Tuesday. You cannot not fall toward it any more than you can refuse to move forward in time. Let that reframe sit with you, because it is one of the eeriest truths these objects hold. We think of the centre of a black hole as a place, a location in space, somewhere you could in principle point to. But once you're inside the horizon, the centre stops behaving like a place and starts behaving like a time. Falling toward it is not a choice of direction. It is simply what the future is. The way tomorrow is what comes after today. Every road leads there. Every direction is the same direction. The whole inside of the horizon funnels inexorably toward that one unknowable point, and nothing that crosses the boundary, no light, no matter, no information, no traveller, can ever do anything but fall toward the place where our understanding ends. The interior of Ton 618 is not a region you could explore. It is a one-way corridor with a question mark at the end of it, and the corridor is as wide as 40 solar systems. There is something almost unbearably strange about an object whose outside we have measured so carefully, and whose inside is, in principle, beyond all measurement. We know the weight of Ton 618, the width of its horizon, the speed of the gas around it, the age of its light. We can write all of that down in numbers, and then we reach the boundary, the edge of the shadow, and everything we can say simply stops. Not because we lack a better telescope, but because the very idea of information from inside is meaningless. Nothing that crosses the horizon can ever send anything back. The interior of this object is the one place in the entire universe that is permanently, structurally sealed off from observation, not just far away or faint, but causally cut off, walled away by the geometry of space and time themselves. Whatever happens in there happens in a region that can never, even in principle, communicate with the universe outside. So the largest object we have ever found is also, at its centre, the most absolutely hidden, and the two facts are the same fact wearing two faces. The thing is so massive that its gravity seals a portion of reality away forever, and that sealing is exactly what makes it a black hole in the first place. To be that big is to carry at your centre a secret that the universe itself is built to keep. And there is one more strangeness to fold in, because it ties the size of this thing back to time in a way that matters. Near a black hole this massive, time itself runs differently. The closer you draw to the horizon, the more slowly your clock ticks compared to a clock far away. For an outside observer watching you fall toward Ton 618, you would appear to slow, to redden, to freeze. Your final approach stretched out longer and longer until you seem to hang motionless at the boundary forever, your image fading but never quite vanishing. The monster does not just bend space into a sphere 40 solar systems wide. It bends time, slowing it, stretching it, so that the very meaning of when and how long comes apart at the edge of the thing, just as our ability to picture how big and how heavy came apart on the climb. Every measure we live by, size, distance, weight, time, phrase at the boundary of this object. It is not just too large to imagine. It is a place where the ordinary fabric of measurement itself begins to unravel. So what waits at the centre of the biggest black hole we have ever found? The most honest answer I can give you is the most unsatisfying and the most wonderful one. We do not know. There is a point there where matter is crushed beyond anything our physics can describe, where space and time curve past the edge of our equations, where the very best understanding our species has assembled falls silent. The outside of this object broke your imagination. The inside breaks our science, and both of those breakings I think are gifts rather than defeats, because they mark the exact boundaries of what minds and theories can presently reach, and there is something clarifying about touching those boundaries directly, about standing at the edge of the known and feeling, honestly, how much further the unknown extends. We have one more thing to do tonight, one last rung, and it is not a step outward to larger objects or inward to the centre. It is a step in time, toward the far future, to ask what becomes of a thing like this when everything else is gone. Part 12. The Thing That Outlives the Stars. We have been treating Ton 618 as a thing in space, an object of enormous size and weight, but everything in the universe is also a thing in time, with a past and a future, and the future of a black hole. This massive is one of the strangest and most enduring stories in all of nature. To tell it, we have to leave the present entirely and travel forward, far forward, into spans of time so long that the entire history of the universe so far becomes a brief flicker at the very beginning. And what we find out there, in the far reaches of cosmic time, is that this monster is not just one of the largest things in the universe. It may also be one of the longest lasting, an object that will still be here long after almost everything you have ever known or seen has faded into darkness. Begin with the present and look ahead. The universe right now is full of light, full of stars, hundreds of billions of galaxies each blazing with hundreds of billions of suns. But this bright era will not last forever. Stars burn through their fuel and die, and while new stars are still being born, the rate of new star formation has been declining for billions of years already. Run the clock forward far enough, and the gas that makes new stars runs low, then runs out. The last stars will form, and then, one by one, over enormous stretches of time, they will burn out. The bright galaxies will dim. The familiar sky, full of light, will slowly go dark, until the universe becomes a cold and quiet place, scattered with the burnt-out remnants of stars, drifting in an ever-expanding darkness. This is not speculation in the loose sense. It is where the physics points, the long, slow, winding down of the age of starlight. And through all of that dimming, through the death of the stars and the fading of the galaxies, the black holes remain. They do not burn fuel. They do not run out. A black hole like Ton 618, having grown to its monstrous size, simply persists, sitting at the centre of its galaxy as the stars around it die and the light goes out, enduring while almost everything else ends. As the galaxies themselves slowly come apart over unimaginable spans of time, their stars flung away or swallowed, the great central black holes will be among the last large structures left standing, dark and silent and immense, floating in a universe that has largely gone out. The thing we have been calling a monster all night turns out to be, on the longest timescales, something closer to a survivor, an object built to outlast the light. Let me put you there, in that far future, for just a moment, because it is a place worth visiting, even though no one ever will. Imagine drifting in that cold and darkened universe, long after the last star has died. There is almost nothing left to see. The galaxies have come apart. The sky holds no bright points, no warmth, no familiar constellations. Space has stretched so far that even the dead remnants of stars have drifted beyond one another's reach, each alone in an enormous emptiness. And there, in that near-perfect dark, still hanging where it always was, is Ton 618, or what it has become. It gives off no quasar light now. Its feeding ended billions of years in our own past. It is simply there, a region of darkness, 40 solar systems wide, having outlived the stars, the galaxies, the entire bright chapter of the universe's life, a monument in the black to an age of light that has ended. But even a black hole is not truly eternal, and this is perhaps the most astonishing part of all. It turns out that black holes are not perfectly permanent. Through a subtle process at the very edge of the horizon, a black hole very, very slowly leaks energy back into the universe, radiating away a trickle of warmth so faint it is almost beyond imagining, and over time, an almost endless span of time, this leakage causes the black hole to shrink. Given long enough, a black hole will evaporate entirely, dwindling away until nothing is left. For a black hole the size of Ton 618, the time required for this is so long that it makes everything else we have discussed tonight seem instantaneous. We are talking about a span written as a one followed by roughly 100 zeros in years. Not billions, not trillions. A number so large that the present age of the universe, the whole 13.5 billion years since the beginning, is less than a rounding error against it, less than a single tick at the very start of an almost infinite clock. I want to make sure that comparison does not just wash over you, because it is one of the most extreme in all of physics. Take the entire age of the universe so far, the whole 13.5 billion years from the first instant to this very night, with all of cosmic history packed inside it, the forming of galaxies, the birth and death of generations of stars, the cooling of worlds, the rise of life on at least one of them, all of that, the complete story of everything that has ever happened, fits inside 13.5 billion years. Now set that span against the lifetime of Ton 618, the time it will take to slowly evaporate away, a 1 followed by something like 100 zeros in years. The age of the universe is not a small fraction of that lifetime. It is so vanishingly small a fraction that if you tried to mark where we are now on a timeline stretching to the black hole's final evaporation, the entire history of the cosmos so far would not even register as the first faint dot at the very beginning of the line. We are not in the early universe. We are in the newborn universe, the first breath of it, a fleeting bright instant at the dawn of an almost endless darkness, and the black holes will preside over nearly all of the time that is to come. Everything we call history is happening in the opening flicker, and Ton 618 will still be there, fading, for essentially the whole of eternity that follows. Sit with the scale of that for a moment, because it folds time and size together in a way that returns us to where we began. We started tonight with light. We said that light crosses the solar system in hours and the galaxy in 100,000 years, and that this same light needs 2 full weeks just to cross the event horizon of Ton 618. That fact felt staggering then. Now place it against the lifetime of the thing. The light that takes 2 weeks to cross this object will keep crossing it, edge to edge, over and over, not for billions of years, not for trillions, but for a span so long that ordinary numbers fail, and we are left writing a 1 with 100 zeros after it. This single dark object will sit in the universe, enduring, outlasting the stars and the galaxies and the whole age of light, for longer than the human mind has any way to hold. It is not only too big to imagine in space, it is too long to imagine in time, and there is a quiet grief braided into the wonder of this, which I think is worth naming honestly rather than rushing past. Everything you love is temporary on the scale this object lives by. The sun that warms your days will die. The stars you can name will burn out. The constellations, the familiar shapes of the night sky that humans have looked up at, for as long as there have been humans, will dissolve as the stars that form them go dark and drift apart. All of the warm and familiar light of the universe is a brief early chapter, and it will end. And when it has ended, when all of it is gone, this thing, this monster in the constellation of the hunting dogs will still be there, fading so slowly that its dying takes longer than the entire age of light it outlived. There is a strange and steadying comfort in that, at least for me. The universe does not end when the lights we know go out. It goes on being enormous and strange and enduring in the dark for spans we will never witness, around objects we can never reach. We are a small bright moment near the beginning, and it is a privilege, I think, to be the kind of small bright moment that can look ahead into all that darkness and understand, even a little, what waits there. Part 13. A scale you were never built for. We have reached the top of the ladder, or as near to the top as we can see, and it is time to climb back down to where we started, to the ground beneath you and the ordinary ruler you carry for the size of the world. But you will not carry it quite the same way now, and that change, small and quiet as it is the whole reason we made this climb. So let me gather up what we have seen and hand it back to you, gently, the way you return something to a person that they did not know they had lent you. We began with the word big, and with the largest things your own eyes have ever stood in front of, the oceans and mountains and long horizons that built your private sense of scale. And then we climbed. We left the ground for the planet, and the planet became a grain beside the sun, and the sun became a speck at the center of a solar system that light needs hours to cross, and the whole solar system became nothing against the 4-year leap to the nearest star, and that leap became a single short stride within a galaxy 100,000 years wide. We met the dark holes at the centers of galaxies, 4 million suns in ours, 6.5 billion in the one we photographed. And then we met Ton 618, 66 billion suns, more massive than every star in our galaxy combined, its event horizon 40 times wider than the orbit of Neptune, so large that light itself needs 2 weeks to cross it, so far away that its glow is older than the sun, so enduring that it will outlast the stars by a span written as a 1 followed by 100 zeros. And at every step you felt the same thing happen, the thing I promised you at the very beginning. The numbers stayed perfectly clear and the pictures quietly failed. You know exactly how massive Ton 618 is, and you cannot see it. You know exactly how wide its horizon is, and you cannot picture it. We even changed the central number, cut it from 66 billion down toward 40, and your inability to imagine it did not so much as flinch, because a number is not the same as a size, and somewhere on the climb the two of them let go of each other and walked apart inside your own head. That parting is not a failure. It is one of the truest things you can ever learn about your place in the universe, that what is real keeps going, on and on, long after what you can imagine has stopped. And notice, if you will, the quiet achievement folded inside that humbling. We could not picture this thing, no, but we found it. We weighed a shadow 10.5 billion light-years away by reading the blur in a faint smear of ancient light that left before the sun was born. We worked out the width of a darkness we will never approach, the temperature of gas we will never touch, the shape of an interior we can never enter, the length of a future we will never witness. Every single one of those facts came to us across a gulf no spacecraft will ever cross, carried on nothing but light, decoded by patient people in quiet rooms over long careers. There is a strange and beautiful symmetry in it. The same imagination that fails to picture Ton 618 is the imagination that reached out and found it in the first place. We cannot see it in our minds, and yet we know it is there, know its weight and its size and its age, know it more thoroughly than the astronomer in 1957 who looked straight at its light and saw only a faint blue dot. The not seeing and the knowing live side by side in us, and somehow both are true, and somehow that is the most human thing of all, to hold, at once, a fact we are certain of, and a picture we will never have. I want to leave you with the reframe I promised, the one that turns all of this from a story about smallness into something gentler. It is easy, facing an object like this, to feel diminished, to feel like a speck, to feel that the enormity of the universe is a kind of insult to the smallness of a human life. But I do not think that is the right feeling, and I do not think it is the honest one. Consider what we actually did tonight. We are creatures the size of a doorway, living on a grain of rock, with lifetimes briefer than a single flicker of the clock this monster keeps. And from that tiny vantage, with nothing but the light that happened to fall into our telescopes, we reached across 10 billion light-years and weighed a shadow we will never touch. We worked out its size, its distance, its age, the strange one-way geometry of its interior, the almost endless span of its future. We found the precise place where our imagination gives out, and instead of looking away, we walked right up to that edge and stood there on purpose. That is not the act of something insignificant. The universe is enormous beyond imagining, yes, and we are small within it, also beyond imagining. Both of those are true at once, and they do not cancel. A thing can be small and still be the part of the universe that looks up and understands. Ton 618 has been hanging out there in the dark for billions of years, indifferent, unwitnessed, larger than any mind could hold. And it took a species of small, brief, soft-bodied creatures on a single ordinary world to find it, to weigh it, to feel their imagination break against it, and to choose to find that breaking beautiful rather than frightening. The smallness you feel looking up at a thing like this is not a wound. It is the particular smallness of the only kind of thing in the universe that can feel it at all. Think about how rare that actually is. The universe is full of enormous things, and almost none of them know anything. The stars do not know how large they are. The galaxies do not know they are turning. Ton 618 has been hanging in the dark for 10.5 billion years, more massive than a galaxy of stars, and it has never once known its own size, never felt its own enormity, never wondered about anything at all. For nearly all of cosmic history, the largest objects in existence have gone entirely unwitnessed and entirely unaware. And then, on one small world, in one brief window of time, there arose a kind of matter arranged so cleverly that it could look up, gather the ancient light, and work out the weight of a shadow on the far side of the visible universe. We are the part of the cosmos that woke up. We are the place where the universe finally turned around and began, however dimly, to understand itself. That is not nothing. That is, as far as we know, the single most unlikely and precious thing that has ever happened, and it is happening inside you right now, as you lie here and let your mind stretch toward an object it cannot picture. The monster is large, you are small, but only one of you is awake. So the next time you stand somewhere and feel the old word big rise up in you, at the edge of an ocean, or under a mountain or beneath a sky full of stars, let it carry a little more than it used to. Let it carry the knowledge that there is a thing out there, in the direction of the hunting dogs, that your imagination cannot reach, and that this is not a cause for despair but a kind of company, because every human who has ever lived has been exactly this small, beneath exactly this much sky. The ruler is broken. It was always going to break, and on the far side of where it stopped measuring, the universe simply keeps going, enormous and quiet and strange, full of monsters we will spend the rest of our existence learning to find. We weighed one of them tonight, a shadow 10 billion light-years away, and we could not picture it, and that, in the end, is one of the most wonderful things a mind has ever managed to do. Rest now. The monster is still out there, exactly where it has always been, and it is in no hurry at all. Neither tonight are you.